Okay, there we go. We're done with the interact. Welcome back. Now we're going to look at that function again and answer the question, is f of x equal to absolute value of x plus 2, 1 to 1 or not? So from the book, there's a definition, and the book actually gives two definitions, but we're going to look at one of them today. So this is basically verbatim, just cut out a couple words, some of the slight details, but basically reading straight out of the book, it says a function f is a one-to-one function if whenever f of a equals f of b, then a equals b. Or let's say this in different words, if you have two output values, two y values of the function f, if they're the same, if they're equal, then it's because you were using the same input. And the book also gives another tool called the horizontal line test. Right? And let's recall what that said. Quoting straight from the book, it says that a function f is one-to-one if and only if every horizontal line intersects the graph of f in at most one point. So both of these things, this definition here and the horizontal line test, give us two methods to figure out if this function is one-to-one or not. So let's first look at the definition. And this will give us method 1. Okay, the algebraic method of finding out if the function is one-to-one or not. So I just wrote it here again, so it's on this slide. Whenever f of a equals f of b, then you have to have a equals b. And what I'd like to do is look at that table that we computed earlier of values. Remember we picked random x values and got y values. So I just Control-C, Control-V that table right here. This table looks familiar. It's in part 1 of this two-part video series. And what I'd like to do is notice these two numbers right here. Here we have f of something equals 1 and f of something equals 1, right? And this is really going to be our cause for concern. What we did was, when we plugged in x is equal to -1 into the formula, we got y is equal to 1, or f of -1 equals 1. We got f of -1 equals 1, and we also got f of -3 is equal to 1. So let's summarize that right here. We had both of the things on the left and the right side of this equation are both equal to 1, right? This right here is really this one, and this right here is the other red one right there. Okay, so we have f of -1 equals f of -3, and if we follow along with this, whenever that happens, we should have that what is a? It's the thing in the first set of parentheses. Then the -1 should equal -3. So let's read this off. But those are not equal, right? So f of -1 does equal f of -3 since they both equal 1. Yet -1 is not equal to -3. So therefore, this statement right here, whenever f of a equals f of b, then a equals b, that statement is not true. And we showed this using a equals -1, that's the thing in this first set of parentheses, and b equals -3, that's the thing here in this second set of parentheses. And we can conclude from this, therefore, that our function is not one-to-one. Now, there's a second method that we can use to see if the function is one-to-one or not, and that's going to use geometry. So let's go to the picture. We recall that we had this was the graph of f of x equals absolute value of x plus 2, and we're going to run the horizontal line test. So we should ask if we can draw a horizontal line somewhere which will cross the blue graph more than once, so twice or more is another way to say that. And this red horizontal line will do the trick. Where does it cross? At these 2 points that are shown right here. Okay, so I'd like to summarize why the horizontal line test, fails and what's going on, but I need a little bit more room. So let's throw this up on the next slide and just make it a little bit smaller. Okay, so there it is. And recall the horizontal line test. It says that a function f is one-to-one if and only if every horizontal line intersects the graph of f in at most one point. But there is a horizontal line, and we discovered it just earlier, that intersects this graph in more than one point, right? So this red horizontal line intersects the blue graph in 2 points. So because the red horizontal line, which is specifically the line y equals 1, because that red horizontal line crosses the blue graph of f twice, the horizontal line test, shown here, fails. So we conclude the function f of x equals absolute value of x plus 2 is not one-to-one. Okay, great. So if you were to write up your solution and you were to use the second method, it's good to have text that looks something like this, right? This is reasonably written in complete sentences, and this shows exactly, your thought process and what was going on. Likewise, if we go back for a second to the first method using algebra, if you were to write your solution using that, it would be good to show this computation that you picked x is -1, you plugged in and show that this is the y value. Same thing if you plug in x is -3, that you get +1. It's good to write a sentence that looks something like this, something that looks like this, and then to write your conclusion out in words like this. You'll notice that really in some sense, there are some formulas showing up here, but really this, and this, they're all more or less complete sentences. And same thing in the second solution, writing something like this, restating the horizontal line test, providing your statement that there is a horizontal line that crosses more than once, and writing exactly what line that is, perhaps drawing an arrow to the line that you've drawn and showing the two crossing points. If I had the technology, maybe I'd take this twice and draw an arrow from twice, once to this dot and once to that dot. That kind of thing would help clarify to somebody who's not quite sure what's going on inside the picture. All right, thanks for watching.